So this is a follow-on to tokenization and really protecting PII, personally identifiable information. And it is not easy to get right, and you got to be pretty dedicated, and it causes certain issues. While, every solution you pick, whatever problem you solved, you create another problem. So what is tokenization? Tokenization is a way of obfuscating or isolating personally identifiable information so that the actual values don't exist in most of your data store. So this reduces the attack surface PII loss by reducing the number of places the data actually exists. Everywhere we would have a personally identifiable, pretty much everywhere we're going to have PII. We would replace that with a tokenized equivalent. We've also done this with encryption in the past. And really, an encryption and tokenization are two, field level encryption and tokenization are two approaches, different approaches to the same problem. But they have differences. I think in the other talk, I talked about why one might be better than the other. So basically, the PII is replaced by tokens that can be repeatedly regenerated. So every place you use the same value for the same PII field, you should get the same token. Systems operate with a list privilege. This should operate with least privilege and only escalate PII visibility and access to data when required. So like in the user interface for a customer, they're going to see their PII. But everywhere else in the system, there's really no need for that PII. Right? We just need the ability to get back to it. And so we're going to store a token everywhere we would have put that PII. So like if their social or that'd be social security number, their driver's license, their last name, first name, birth date, all that kind of stuff, we would store a token everywhere. And that will cause certain problems. And because this is going to be an interceptor, basically, in between everywhere data is used in an API and everywhere it's stored, it's got to be a high-speed, low-latency system. So handling PII and tokens. The PII is stored in a PII hardened zone where, you don't have to call it a zone, but it's basically network isolation, physical, some kind of logical, physical isolated area where you basically create a bubble that holds the PII, and it have very few ins and outs, maybe one, and it can only happen via some API, and nobody has access to that PII zone. Really, you basically have to be have crazy privilege, and it would be something temporary. And the applications convert the PII to tokens for storage, and then they convert it back into PII when it's presented, or if something. And so whenever they're interacting with a customer, some PII aware system, they end up having to do that conversion back and forth, but the data is never persisted in the PII form. Right? It's always in the tokenized form. And this really crushes partial search. So if you're going to do partial search, like my name's Freeman, if you were going to do FREE and then star, that becomes a problem because we actually don't have the real values in the system. So this partial text search is probably, in my mind, the biggest problem with tokenization or encryption. I've used both, and they both have it. The other thing that turns out is machine learning may actually, if you're going to do fuzzy identity resolution, or you're going to do machine learning for fraud or machine learning for addresses that are close to each other, that kind of stuff. A lot of times machine learning actually works with production data, and so you end up needing a machine learning zone, basically, that is highly restricted that can be used for training. So sample topology, man, I tried to use new color scheme. This is horrible. So basically what you end up with, the important part is the operational zone. And so when the operational zone interacts with the users, they see the non-tokenized version of their data because nobody wants to see XXX for their last name. That's confusing. And that data is stored tokenized in the operational zone. And then you have a PII hardened zone. You might call it something else. A lot of times they have different names. But basically, anytime data needs to be persisted in a non-PII zone, basically it goes through the tokenization service. Tokenization service stores a mapping from the token to the value for a given field, and I'll talk about that. That tokenization PII store is segmented by the field name, or so it would be like a last name would have its own first name, all that kind of stuff. And you're going to end up needing a high-speed token cache, and I just put that in as an implementation detail. So you can tokenize and detokenize between the service tier storing and the service tier talking to the UI, that kind of thing. And then those tokenized values can get moved from the operational zone to an analytical zone, which would be like a data lake. And so in your data lake, you would only have, because a lot of times you're doing statistical things. Like you might be able to leave states or some other things. But like if you were going to try and do some aggregating based on a zip code or something, if all the other data is tokenized, you might decide a zip code by itself is fine. So if that might change what you declare as PII, because sometimes things are PII only if they're combined with other fields, right? So the tokenized value would get moved into the data lake. All the ingestions from the operational zone to the analytical zone would end up stored with no PII. They would be tokenized. And then you would have a process if you ended up with an ML modeling zone. That data that got promoted from the analytical zone to the ML modeling zone would end up having to be detokenized if those features creation ended up needing to be trained with data. Like we're going to do it based on street address and zip code. We're going to do it based on, I don't know, combination of different things. We're going to train based on their email address, their last name, and their street address or something. I don't know. Anyway, so the point was the two red zones basically have PII in them and the two blue zones don't. So PII zone set up before it's a hardened zone. It's basically could be a network, could be a subscription, could be an account in the cloud somewhere. This effort is only useful if you can, so doing everything with tokenization, it's only useful if you can protect the tokenization API and you can protect the tokenization data store. In the same way you need to protect your encryption keys. If you're going to do encryption, no people should be allowed access to data in this zone. Nobody needs to do that. When you're doing triage, it really doesn't matter. And if you need somebody to have access to some PII, you should build an API and a web interface for it, right? Nobody should be looking at the data store directly, so that all that data should be restricted. Access should be the API, and the API needs to be super robust and secure because basically, now what's interesting here is the way the tokenization thing works, it doesn't commingle all of the data that would be PII. So if I had my first name, last name, my street address, my SOC, those actually end up in 4 different areas in the tokenized store. So if you steal that entire store, you actually don't know the linkages between that. So it's a little better, right? For all those PII fields would become burst apart and be kind of tokenized separately. So no individual field by itself would tell you who a person is. So basically the way this works is every type of PII has an attribute key. So in this case, I have last name, first name, date of birth. In this case, the key is LNFNDOB. That means you have to have a standard schema, right? So last name always has to have the same key, because what you want to be able to do is equality testing. Is this guy's last name the same as this one? Is her last name and first name the same as this other last name and first name? And to do that, you need to have a repeatable bidirectional tokenization and detokenization process. So in this case, what all this really calls out is that every field ends up with its own table or data store with its own token and value pair from the tokenizing process. Now, the thing I just jumped into a minute ago is the same value in the same field should all bind to the same token so that you can do equality, right? If I have a last name in my bank account and a last name on my savings account, and I want to know all the people that have a last savings account and a checking account, right? Then I would want the last name, first name, and all those fields if I was going to do it, entity resolution that way. Those all need to map to the same value. So in this case, this was 3 last names in 3 different apps. They all generated to the same token, so that meant they all mapped to the same token in the token store because they were considered equivalent, right? We want to make equality still work here. So the same last name for multiple apps generates the same token. Standardization is important because to make that work, you got to use the same field names, right, to the key so you know which partition in the token store you're in. The other thing is if you want to do identity resolution, like for email address, you may actually want to tokenize it in some standard format internally and remove the capitalization. The problem with this is you end up in a destructive, you end up destroying it, right? So when you do the detokenization, you're actually going to get back the value that everybody else saw in there, right? To make this equality thing. So you just got to realize if you do this equality thing, if you really need the exact original formatting, like I want my capitals in my name to be exactly a way, you may end up deciding to risk token equality. You got to decide which one's more important, token equality or the original values. For street address, nobody cares. But for a last name, you might decide you go with theirs, but that would make somebody in all lowercase and somebody in all uppercase, those 2 names, not pass the equality test, and that's really up to you. That's your business use case. So, and this is an example of canonicalizing to a standard or standardized email address. I might actually want to store it all in lowercase and generate the token for the lowercase. And I actually could, I don't know how you do that, but you could end up using the same token for two different values, the original and a lowercase. And so you could bind it back in there. The problem is basically, if anybody detokenized something, are you going to give them all lowercase back or the original? And that affects your equality, because if you give them the originals back, then the tokens won't be the same. You got to decide what problem you're actually serving for. In an analytical store data lake, you don't care. Probably all lowercase is fine, and then you get this great equality thing. In the operational storage, you'd have a decision to make. And you can do encryption, but then you do encryption, and your names won't match either, because one of them wasn't encrypted upper lower, and the other was all upper because that was the way it was entered. You just got to decide which problem you want to solve. Trade-offs and questions. Basically, this is just kind of some questions you got to think about when you're working on this. So protecting PII via tokenization or encryption takes discipline. You really have to decide, are you serious about this? And are you okay? Is protecting the data more important than some ease of use? Like search and identity resolution is really hard with tokenized. You might end up with it needing a detokenized store just for those capabilities, and then you got to decide what that means. Like maybe you put it in the token service itself. I don't know. Anyway, that's all I got. I hope this answers some of the questions people have. Have a great